So most of you have been in the class with me before, but you two have not. We kind of have a routine. You'll get used to it. Okay. So right now, I'm having issues with my screens because there are three. Screen. My computer doesn't like that, so I can't show you my YouTube channel yet. But most of you know that I have a YouTube channel. All of our lessons are recorded to it. Okay, so if you have trouble at home, you can load up the video from today and look at it. Okay.
Are videos on the on it?
They are on our Grand Valley High School YouTube channel. Yes. I can show you that too tomorrow. I don't want to mess up my pretty white screen right now because I got it and I don't want to change it. But now it's I can actually write stuff for you and then we'll record it. So I'll show you that tomorrow or the next day. But we are right now being recorded and anybody in the world could listen in. It's live. It's a live stream. It posts automatically to my YouTube channel. Okay. Just like last year. So, fat food. It is fat food. In 20 years, it's going to be fat food. Okay, so I kind of framed this for you. How far, does anybody know how far Denver is from Parachute?
246 miles.
Long. You're close. It's just a little factoid. It's 180 miles. Ish, depending on where you're going in Denver. How long does it take to get there?
3 hours.
3 hours, that's, yeah, I mean, that's. Right? Bonus point. How would I calculate my average speed? Yeah. Divide, yeah. So. All right, average speed. What do I need to add to that to make it velocity? A direction. What direction are we going? This right there, the difference between those two can earn you points in AP. Okay, so know the difference. We're already checking things out. These are both rates of change, right?
Wait, the admin direction to get it to be velocity.
Yes. Or a positive or negative sign, but we'll get into that. Those are rate of change. Okay. There are other ways to write this. Does anybody know what mile marker our exit is on the freeway?
41.
You're guessing.
I'm close.
I only know because I'm a math guy and I pay attention to this kind of stuff.
I know it's still.
Is mile marker 75? Thank you. Who said that? Sometimes. Hey, Denver is somewhere in the 255 range. I mean, it's like 20 or 30 miles across Denver, of course, but we'll just put this for sake of the argument. let's say we started at parachute at time 0. 0 hours, and arrived in Denver at time 3 hours. Yeah? Can I do the same calculation with this information? Yeah, I can, right? So I would write my position change. 255 minus 75 over time change. This started to look like slope, right? Look familiar? It's a slope calculation. Kind of stringing it along here. Okay, another way to earn points in the AP exam, include units in your answer. What are my units? Yeah, miles and hours. So, just little, those are little details, but they're details that you should know, and they should be easy for you to put on paper. There, for purposes in calculus, I'm kind of building you into writing this in a different notation here. I could call this, your book uses S. That means position 0, or the first position. And I can call this S1, right? You can code those in. As position is generally used S, and time is always T. Right? You okay with that? I could write this as right. These are all the same thing. Yeah. This is getting into more function notation. Any questions? You okay? Keeping up? Make sure I'm on the right track. Okay, here's another way to write it. Tell me if you can get this. That is not what I wanted to write. It's just flat ugly. Function notation. Yeah. Velocity. Speed is just a number, how fast you're going. Velocity is a speed with direction. Okay, so it's speed. Okay, I'm walking, it doesn't matter which way I'm going.
And it's no different if I have 60 miles per hour or 60 miles per hour east.
Yeah, that's just the difference in meaning.
Okay.
So
So
if I'm gonna do my velocity, this would be 60 miles an hour south, that's velocity. 60 miles an hour north. Okay. As opposed to speed, where I would just say I'm going 60 miles an hour. There's no direction. That makes sense. Other questions? No? function notation. This is the position at time one, which is of course, this would be a one. Sorry. Position at time one is 255, right? Position at time 0, 75. So again, same calculation, different notation. You're going to see that a lot this year. We call this average rate of Are we good? Here's an example. A stone that I want to drop on your head is released from a state of rest and falls at that rate. It's a function. Does it look familiar? Galileo's formula. I think we might have tested it last year. In fact, I know we did. S of T.
What does
You
the
don't
S,
write on a board for 3 months and kind of.
what does the S stand for?
Position.
Why is it S? Is that like,
Because that's what the book says.
I know, but is that like just something you're doing, or is that like,
No, that's straight from our book. That's very standard notation. Um, Okay. I should, you know what? I think we get messed up there. I gotta work this better. That's not right. Okay, that should make it more clear. We're gonna compute that. Okay, so this is the position equation. So anywhere at like time 1 second, you can plug 1 in and get the position, correct? Let's calculate the average velocity from t equals 0 to t equals 2 seconds. You could also write this here. In interval notation. These say the same thing. You'll see this a lot in calculus. You'll see it a lot in your assignment, actually. But, so know that those mean the same thing. These are x values in an interval. Okay. And again, here's our function, right? What's our change in position? position change. And remember that from last year, the triangle? Just quite a bit. And what's our time change? You okay, Gabe?
Yeah.
So what's S at 2? And S at 0. Right. Yes,
So, is the change in position always go on top?
yeah, those are your Y values. Slope is Y over X.
Mm.
That's what it is. Because time is always your X axis. Yeah. Anybody got that calculation worked out? It's 9.8. Did I include units? No, I did not. So if you're not asked to generate units, I'm gonna make you do it here, but on the AP exam, you don't have to. We can put it in meters, since meters are such a better measurement than feet. What are my units? Why is this a velocity? Yeah. We know it's going down. How do we know that? This function defines itself as falling object. Falling object gaining speed has to be positive. If this were negative, what would be happening? It's going up. That's where your direction comes from, the velocity. Okay, so keep those things in mind when we're looking at this problem. So that's average rate of change. Where we're headed with this for calculus is instantaneous rate of change. So imagine you're driving to Denver. What was our average rate of change? 60 miles an hour? What if a cop car busts you at 80 going through Glenwood Canyon? Oh, it only happened because you allowed it?
Yeah.
Wow, you powerful. Yeah, that's what is happening at that moment, correct? That's instantaneous rate of change. When a cop gets you on the radar, 80 miles an hour, that's your instantaneous rate of change. Your speed at that one moment, correct? Okay. We will be able to, in the next 2 months, calculate those precisely. For now, we have to actually estimate it. So how would I estimate? You guys okay with that? Shorthand? Estimate instantaneous rate of change at t equals 0.8 seconds. Well, there's a hell there. Anybody? Ideas? So this is what you're thinking? Okay, what does the function give us? What? It's position. So this only gives us position at 0.8 seconds. Because that doesn't give us rate of change. Rate of change is a slope calculation. So how would I use slope calculation to get this estimated? Estimated. Give me an interval. How about what if I use that interval? Is that pretty darn close?
Yeah.
Yeah, it will be an estimate, right? It's not exact, but this will give us an estimate of 0.8 seconds, right? So I would do that calculation is going to estimate the instantaneous rate of change. Got it?
So you have to, so you do have to plug the 0.8 into the equation, but you have to also plug in something close to it,
Yes, to get it.
and then calculate it.
So this doesn't give us any rate of change information. This is position. In order to get a rate of change, we have to do a slope calculation. And at this point, actually, the calculus is easier than this. I'll just be honest with you. Once you get to the calculus, I can tell you the answer is 9.8 times 0.8. Done, okay? And you'll get that fast. For now, we have to estimate. Okay. Anybody have that info? I guess I've already my calculator out. Anybody? Come on, depending on you, you guys were like the ones on it last year. I have 7.889. That's what the book says. Three decimal places, AP standard. Then we can just chop it off. You don't even have to round properly. Just chop it off, man. Truncate, it's called truncating. So 3 decimal places, you have your units. Show your work properly. It's very important that they can follow your work on the 3 responses. Okay?
Wait,
And then I can, thanks for that.
so you don't, it's like 7.8895, you don't have to,
Just get rid of the 5. If you put it, it's not wrong, they'll count it,
okay,
but it's just extra right.
okay.
Okay. If we look at a graph of this, it's a parabola, correct? Yeah. Here's the graphical comparison of these. Yeah. That's just part of the position function. This would be like f of x. So I could write it this, I could write it like this. Is that more familiar? Okay, this, well, what does this tell us? So here's the difference. There's what you're mostly used to, right? Okay, this tells us we have a time. X can be used, yeah, but this is more precise, because it tells us this is time, and the S for the function incomes, it is a position function. Okay. What? I looked at the book.
Okay, then.
I'm serious, that's what it says.
I know, but how the book is. So,
Oh. Okay, here's the calculation.
yes.
4.9. That's the calculation you put here.
Wait, so,
That's this,
That
and
one,
that gives
okay,
you that.
thank you. That
Yes,
helps.
okay. I thought I could skip that. but- Deep breath, are we okay now? We're on track? First hour, calculus BC, they've had this class before? What's the limit? So here's average velocity, algebraically, instantaneous estimate, algebraically, right? Graphically, this is what we call a secant line. That should sound familiar. We went from 0 to 2, right? The slope of this line is 9.8 meters per second, right? Because that was our average rate of change, the slope of that secant line, correct? Right? This is also a secant line, correct? It's got 2 points. This is a secant line as well. It's a much smaller interval, of course. Instantaneous rate of change is a tangent line. So at 0.8, remember from last year, it touches once. So secant line touches 2 points. This is 1 point. Good. Tangent lines are where we're headed with calculus. We can calculate the slope of that with the derivative.
So tangent line is just the single point, so instantaneous,
It's the instantaneous rate of change at this point
and then the secant line is just the average.
over an interval. Right. Yes. That makes sense? Yes, Michelle.
so did you put a 4.9 for the second? For the X?
Here.
Yeah,
You're still here.
well, when you put that equation on that.
Here's the function. Right? At my time 0.81, so I plug 0.81 and square it, multiply by 4.9 minus this square times 4. Are you okay there? All right, turn to page 64. I just want to point something out to you. 64. Look at the exercises just above number 2. See that table? The exercises just above number 2, there's a table.
Okay.
This confuses some people.
Yeah.
The table says you're gonna have to compute these answers. So interval is 2 to 2.01, and you're asked to calculate average velocity, right? 2 to 2.01 is the interval. Average velocity is this calculation. So you have 4 of those to do in that one problem. Does that make sense? Every year it trips up my calc students, this table does. So those intervals, you have to do 4 of these calculations in that table. Right.
Bless you.
Notice the last one is 2.00001.
Yeah.
Getting closer and closer to the real number for that. Okay.
Yeah, I did.
I think that should do it. You have about, I don't know how much time you have, but I'm gonna give you some work to start. Look through it, and if you have any questions, it's a good time to ask them. We'll score it tomorrow, so.
So much all that. Me.
Okay, 34. Once in a while, I will put a problem on here that's from the further insights and challenges section of the book. So it's kind of like my, all right, you can do it. It's a challenge. Yeah, I'm not going to count it against you. This 34, the star. This is a special problem. It's one of those challenge problems. You can do it, sure. Hot dog. Okay.
Do you have the classroom set up for it?
Yeah, we're gonna get to that Friday. I know we haven't touched on the pre-calculus stuff yet, but these are from last year. They're just reminder problems. Wait, these are spiraling, remember? Yes. So this is your main assignment from the new stuff. This is review material.
But do we have to go back?
Yes, you go in your book to 1.4, 10 and 15, and then the chapter 1 review, 7 and 8. Does that make sense? Our book does not have, like, the pre-calc book has mixed review on the end of every assignment. This doesn't have it. So I have to make it myself. Right, so you have to go back to these sections and do those projects. The reason I'm doing this is so I can make sure you got that before I leave. Okay, are we okay? You got probably 5 minutes-ish, 6 minutes, so. Try to get a couple problems done. If you see any that are confusing, just say something, I'll help you. Yes. We will score this tomorrow.
Chapter 1 review. It says on the instructions, do not punch kick.